Hello everyone, my name is Sinja Sharma and today I am going to present my lab-based project, that is Arduino-based self-leveling drone design. Task completed. Theoretical structure of drone: integrating ESCs with Arduino Uno, integrating MPU with Arduino Uno, simulating Arduino plus MPU as flight controller, integrating receiver transmitter module, then studying PID controller and integrating it with ESCs to form flight controller, PID tuning for auto leveling of a quadcopter, and then integrating the Wi-Fi module with Arduino Uno to communicate with the mobile. Integrating MPU9250 with Arduino Uno. MPU is a motion tracking device that tracks 9-axis movement and comprises 3-axis accelerometer, 3-axis gyroscope and 3-axis magnetometer. It is a widely used tool in the robotics and drone application, helps to determine the orientation and movement of a device in space. To communicate with the Arduino Uno microcontroller, the MPU9250 utilizes the I2C protocol, and once connected, it uses the wire library to interact with MPU9250 through I2C. In our Arduino sketch, we use the 9250's default address, that is 0x68, to establish the communication with the device. Now simulating Arduino plus MPU as flight controller using a multi-device software. So basically, I have MPU9250 in my hand, and as I change its orientation and its position, it is recorded in the software as shown in the screen. Integrating ESCs with Arduino. What are ESCs? ESCs stand for electronic speed controllers. They are devices designed to regulate the speed and direction of electric motors. In the quadcopter applications, ESCs are crucial for controlling the speed of each motor and maintaining the stability of drone in the air. Connection between the flight controller and the ESC is established through signals sent by flight controller, which instructs the ESC to regulate the speed of each motor. The ESC is composed of 3 wires: wire A, wire B and wire C. Wire A, or the red wire, is the one which supplies power. Wire B, or the white or yellow wire, is a signal wire which transmits the PWM signal from Arduino Uno to control the motor speed. It is also important to note that the other 3 ESCs must be connected to Arduino Uno in a similar manner but different digital pins 5, 6, 7. The black wire, or the wire C, serves as a ground. Arduino integration with FS100A receiver and transmitter module. It is a pair of 433 MHz wireless transmitter and receiver which is used for wireless communication between Arduino Uno or any other compatible device. Now integrating Wi-Fi module with Arduino Uno. So basically the Wi-Fi module, or ESP8266 ESP01 module, it is an economical and pragmatic solution for the integrating wireless capabilities into the microcontroller and development board. Its interface is user-friendly, making it effortless to navigate and can be programmed using the Arduino IDE libraries that are compatible. So while this module has numerous advantages, it's very important to note that it functions at its best when it has a constant power supply of 3.3 volt and precise linking with the serial communication pins. PID controller. So PID controller is the flight controller's algorithms which we are using in our flight controller to stabilize the drone. So this algorithm comprises of 3 components, that is proportional, integral, derivative, PID, to adjust the drone's orientation by controlling its motor. The PID controller continuously regulates the motor speed to maintain the stable orientation, resulting in smooth and stable flight even in windy situations. Drone flight controller designs necessitates the careful tuning of PID gains based on several factors like drone's weight, motor thrust, etc. The process involves adjusting the proportional, integral and derivative gains to attain the desired stability and performance level. Once we integrate the receiver controller or the Wi-Fi module into our code, we can obtain the PID gains using hit and trial method. Flight controller. So flight controller of a drone is a very crucial component which is responsible for managing its flight behavior, navigation and stability. It acts as the brain of the drone by sending inputs to its motors and sensors. The device comprises of various components and elements like microcontroller, like Arduino, sensors like MPU9250 remote controller, and other components like ESCs, Wi-Fi module, etc. The microcontroller reads and processes sensor data to determine different flight parameters like altitude, orientation, and speed. Based on this information, the flight calculator calculates the appropriate motor speed and sends instruction to the electronic speed controllers to control the speed of each motor. By adjusting the motor speed, the flight controller can manipulate the drone's movement and stability in the air. However, the software algorithms like PID controller regulate the drone stability and response to user input. Once the PID gains value are retrieved, we can conclude that the functional flight controller has been successfully developed. Integrating MPU 9250 to read the gyro input and control the motor speed. So basically in this circuit diagram we have integrated the ESCs as well as the MPU. So this MPU reads the gyro speed and then according to PID controls the speed of the motors which are connected through ESCs. So this is the simulation video. The speed of motor is hence controlled and the output of the gyroscope or the MPU 9250 is also displayed on the screen. The motor speed is also displayed over there. So that was what I have done till now in this project. So in the future I am planning on creating a mobile application which allows for drone control through phone without the need of external remote control, and incorporating various sensor modules into the drone to make it effective, and for various applications which involve first of all to integrate a GPS module which may provide location and amplitude data which can be useful for autonomous navigation, mapping and surveying purposes. Adding a camera to the drone to provide the aerial photography and video capabilities which can be used in applications like cinematography, surveillance and inspection, etc. Installing gas sensors to detect the hazardous gases in the environment which can be helpful for environmental monitoring and industrial inspection. Incorporating ultrasonic sensors to detect obstacle and measure direction that can be used for navigation purposes, collision avoidance purposes, etc. Adding a microphone to the drone to enable the audio recording capacity which can be used for recording soundscape, interviews and other audio related applications. So that has been my time. Thank you. I hope you like the presentation.